everybody, this is Mrs. Show. Today we're going to do 3-2. So make sure you have your notebook out, and in your notebook label this 3-2. Today our objective is to be able to determine whether a representation is linear or nonlinear, and discrete or continuous. Okay, so as we get started here, linear means exactly what it sounds like. It means it makes a straight line. Linear means it's straight line. Nonlinear means it's not a straight line. So if you look at this first picture here of this graph, this is nonlinear. This does not make a straight line. It actually is a parabola that we're going to do a lot of graphing of this year, but that's nonlinear. If you look at this second picture, this is the graph of a straight line. That means it's linear. So look at number one. Okay, when I look at number one, is it a straight line or not? It is. So we call number one linear. Good. Look at number two. Is that linear or nonlinear? Nonlinear. It's not a straight line. And what about number three? Nonlinear. Right, because it's not a straight line. Okay, in your notes, I need you to write this down. Okay, these two sentences. If the slope is constant, it is, okay, so constant means the same. So we're trying to fill in the blank here. If the slope is constant, if the slope is the same, it is linear, right? Make sure you have this sentence in your notes. So if the slope is always the same, it's going to graph a line. Okay, write your second sentence in the notes. If the slope is varying, it is blank. Okay, varying means it varies. It's different. So the slopes are different. If the slope is varying, it is nonlinear. Okay, so what we're going to do is we're going to look at a couple of tables, and I just want you to watch these two. I'll have you try three of them in just a minute. But this is an XY table. So what I'm going to do with my XY table is I'm going to look at my pattern with my X's and my Y's. So in this first table, when I go from 36 to 30, I subtract 6. When I go from 30 to 24, I subtract 6. When I go from 24 to 18, I subtract 6. Now I'm going to look at the pattern with my X's. From 3 to 6, I add 3. 6 to 9, I add 3. 9 to 12, I add 3. Remember, slope is the change in Y over the change in X. So first my slope is negative 6 over 3. And then it's negative 6 over 3, and then it's negative 6 over 3, which all equal negative 2. So this example shows that the slope is always a negative 2. That means it's the same or constant. If I graph these points, it would be a straight line. This is linear. Okay, I don't want to graph. I just want to look from a table, though. So if I was doing the second table, I just need you to watch. When I go from 2 to 9, I add 7. 9 to 20, I add 11. 20 to 35, I add 15. Look at the change in X. First I add 2, then I add 2, then I add 2. Remember, slope is change in Y over change in X. So first my slope is 7 over 2. Then my slope is 11 over 2. Then my slope is 15 over 2. Are all those equal to each other? No, 7 over 2 is 3.5, 11 over 2 is 5.5, 15 over 2 is 7.5. The slope is varying, so this is nonlinear. Okay, so if the slopes are always the same, it's linear. If the slopes are different, it's nonlinear. Remember, when you do slope, you do change in Y over change in X. So now I want you to try these three. Pause the video. Find the change in Y, find the change in X, make them fractions with the change in Y over change in X, and see if the slopes are the same. If they're the same, it's linear. If they're different, it's nonlinear. Go ahead and pause the video now. All right, let's see how we did. So on the first one, when you did change in y over change in x, first you get 16 over 4, then 33 over 3, and then 51 over 3. Well, those don't equal each other. 16 over 4 is 4, 33 over 3 is 11, 51 over 3 is 17. That's non-linear because the slopes were different. Number 2 was linear. When you did change in y over change in x, you got 2/4 each time, which is the same as a half, but they're all equal to each other, so it's linear. Number 3, first you get 4 over 2, and then 4 over 1, and then 8 over 1. Well, those do not equal each other. The slope is varying. That means it is nonlinear. Okay, now I want you to think about linear or nonlinear in a different way by looking at an equation. So an equation is linear if you can write it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. M is your slope, and b is your y-intercept. All right, so basically when I look at this, I think about the y equals mx plus b equation. In this equation, y is always to the first power, and x is always to the first power. It's not an x to the second or an x to the third. If y and x are always to the first power, that means it's going to be linear, and you can write it in the form y equals mx plus b. So if I look at this first equation, y equals x plus 9, x and y are to the first power. This is linear. If I look at the second equation here, this is a y to the first, this is an x to the first. This is also linear. But when I look at this third equation, I have an x to the second, so this is non-linear. If you look at the next equation here, x is your exponent. Okay, x has to be to the first power. You can't have 3 to the x power. This is non-linear. If you graph that, which we will do some of this year, it's not going to make a straight line. If you look at the next one, it's y equals 2 over x. When x is in the denominator, it's really to the -1 power. And we're going to work a lot this year with negative exponents, but x is in the denominator, not the numerator. If it was in the numerator, it'd be x to the first. Since it's in the denominator, it's x to the -1, so this is non-linear. What do you guys think about this bottom one? Non-linear, because x is to the second. Good. Now, if you look at y equals 3.8, notice that you're missing the variable x. That's okay. As long as the variable y is to the first power, this will graph a straight line. This is where y is always equal to 3.8. It's actually going to be a horizontal line where all your y values are 3.8. So this is linear because y is to the first power, even though we're missing an x. And the next one is y equals the square root of x. Well, y equals the square root of x is the same as y equals x to the 1/2 power. The 1/2 means square root. So this is non-linear because x is not to the first power. So when you look at your equations, make sure x is not in the denominator, because if it is, it's x to the -1, which means x is not to the first power. And then also make sure that all your x and y's are to the first power. If they are, you can write it in the form y equals mx plus b, and that means it's linear. All right, 2 more things to talk about. So in your notes, I need you to write discrete domain. We need to know the difference between discrete and continuous. So discrete domain is a set of input values that consists of only certain numbers in an interval. Continuous domain is a set of input values that consist of all numbers in the interval. Pause the video, take your time to write this down. When you get done, hit play. Okay, now that you're done writing that down, here are a couple examples of discrete. Notice in this first graph, x can only be 1, 2, 3, 4, 5. It cannot be the numbers in between 1 and 2, or 2 and 3, and 3 and 4. It can't be a 1.5. It can't be a 2.2. it can only be 1, 2, 3, 4, and 5. It's only certain numbers. That's why that one's discrete. An example of continuous would be if x could be 1 all the way to 5. So it includes all the numbers between 1 and 5, so it's continuous. So if you look at this graph, x is all the way from 1 to 5, including decimals and fractions like 1.4, 2.6. So that's why it's continuous. Okay, I want you to look at these two. Think about the first one. Is it discrete or continuous? Discrete, because it can only be 1, 2, 3, 4, 5, and 6. Can't have a 4.5 or a 4.7. It's only certain numbers, so it's discrete. Look at the second graph. Is that discrete or continuous? This one is continuous because it includes like a 2.1 and a 2.2 and a 2.3. It includes the numbers between the whole numbers, so it's all of the numbers in the interval. Okay, we have one last problem. It says the linear function m equals 55 minus 8.5b represents the amount m in dollars of money that you have after buying the books. So m is how much money. B is how many books you buy. M is how much money after you buy some books. Find the domain of the function. Now remember, the domain are all your x values. It's your input. Your domain is your input. So the domain would be your B. It's how many books you're buying. Well, when I find the domain, I've got to figure out what numbers could be equal. How many books could I buy? Looking at this equation, it looks like I have $55 altogether, and each book costs $8.50 because I'm starting with 55 and I'm subtracting $8.50 for every book. So if I want to find the domain, which is the input, how many books I could buy, what I'm going to do is take that equation, okay, and solve it for B. How many books can I buy? Well, I can't have negative money, so the money I have left over has at most $0. I mean, I can't have negative, I can't borrow. So if I put 0 here and solve this equation to see how many books I could buy for $55, I could add 8.5 to both sides. That means $8.50 times each book could equal 55 because I have $55 to spend. I can't spend more, but if I divide both sides by an 8.5, it's not going to divide evenly. If I take 55 and divide by 8.5, it's like a 6.47 something, 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 something. Well, think about this. If I buy 6 books, I would have some money left over. Because it's telling me I can buy 6.47 books, but that doesn't make sense. I can't buy part of a book. Okay? The most books I could buy is 6. Because if I bought 6 books and I took 6 times $8.50, that would be $51. I could afford that. I have 55. If I have 55 and I bought 6 books, I would have $4 left over. But I can't buy 7 books because that would cost me more than $55. 7 books would. So what would the domain be? How many books can you buy? Well, I can buy 6, but I could also buy 5. I just have more money left over. I could buy 4, I could buy 3, I could buy 2, I could buy 1, and I could buy 0. If I didn't buy any books, I'd have my $55 still. So the number of books that I can buy would be 0, 1, 2, 3, 4, 5, 4, 6. So are those numbers discrete or continuous? They're discrete, right? Because you can't buy part of a book. You can't buy 5.5 books. Okay? You can't buy 1.5 books. You have to buy a whole book. So discrete, you only have part of an interval. You don't have all the numbers. So this is discrete. All right, so hopefully you understand today's lesson. Thumbs up if you do, thumbs in the middle if you sort of do, thumbs down if you don't at all. If you don't know, please go back and review the video. Today your assignment is 3-2 in the Big Ideas website, numbers 6 through 34 even.